Hello, this is Britt Caswell, and this is my next video on the factoring series. I'm going to be teaching you when factoring when a is not equal to 1. So when we have the standard form of a quadratic, such as you see here, when this value here is no longer a 1. This method in particular is called factoring by grouping, and it's probably one of the most common methods that is taught in the United States. So the entire premise of factoring by grouping is to take this middle term, this b term, and to split it into two other terms, and then to factor using grouping and taking the GCF out. So I need to go through and find the factors of a times c. So here's a, here's c, so I'm going to multiply those together and get 12. So I'm going to find the factors of 12. That when I add them together, or when I find their sum, they add up to that b term, which is 7. So when I think about 12, I think about 1 and 12, 2 and 6, and 3 and 4. So when I add these together, 1 plus 12 is 13, 2 plus 6 is 8, and 3 plus 4 is 7. So I will be splitting that 7x into the sum of 3 and 4. I usually show that by putting this little caret top here. So that 7x is actually 3x plus 4x. Now mind you, everything else in this problem is staying the same. I still have a 2x squared, and I still have a plus 6. Now the next important thing to remember is that when I go to split this up, I need to make sure I have a plus sign between these two expressions. It is a sum, specifically. Now if this had said minus 4x, I would put plus negative 4x. So now what I need to do is I need to group them. So I'm going to split this into two sets of parentheses, making sure that I have this plus in between. If there's not a plus in between, this method will not work. So now I need to go through and find the GCF of each set of parentheses. So in this first set of parentheses, the biggest value that I can divide out of everything is just an x. So if I do divide x out of this, I'm left with 2x plus 3. So now if I go to my second set of parentheses, the GCF between 4x and 6 is 2. And that also leaves me with 2x plus 3. So notice what I'm looking for here is I'm looking to make sure that I have two parentheses that perfectly match each other. So my last step to create the factored form, which is two expressions being multiplied together, is I take everything that I factored out in terms of GCFs and I put it here in the front. And then the expression that I have copied gets multiplied to that. And there it is in factored form. Alrighty, so let's do that again. So first thing, I take a times c and I multiply them together. So 2 times negative 12 is negative 24. So I'm going to find the factors of negative 24. And they have to sum to that b term. So they have to add up to my b term. In this case, it's negative 5. Now, an idea with sums here is that when you have that, I know that I'm going to have a positive and a negative factor, and I know that my negative value has to be bigger for this to be a negative 5. So when I list off my factors, my bigger value between each factor pair will be the negative 1, so that I get the proper signs here. So I have 1 and negative 24, 2 and negative 12. I have 3 and negative 8, 4 and negative 6. So then when I go to add them, I get negative 23, negative 10, negative 5, and negative 2. So here's my pair. Now remember, on my last problem, I told you to make sure that there's a plus between the two factors. So when I do this, I can either write plus 3x plus negative 8x, or I can write minus 8x plus 3x. Either way will get you to the same result. Now understand, I still have my 2x squared, and I still have my minus 12. I just split that 5x into these two terms. So then now we go ahead and we group them, and we make sure that when we group this set of parentheses, that plus sign is in between. I often like to highlight it to make it very clear that I have a plus between them. Our next step is to factor out the GCF of each. So the GCF between 2x squared and negative 8x is a 2x. By dividing that out, that leaves me with x minus 4. When I look at my second set of parentheses, 3x and negative 12, I could factor out a positive 3. And that also leaves me with an x minus 4. So we want to make sure that the parentheses that are left match. I'm going to go ahead and write that copied set down here. And my other parenthesis is everything that we've factored out using the GCF, so my 2x plus 3. And there it is. So let's go ahead and let's do another one. Now, notice here, I have a 10 and a 20. So if I multiplied that out right away, I'd be having to find the factors of 200, which I can absolutely do. It just tends to be a lot more work. So what I'm going to do here is I'm actually going to start by looking for a GCF between 10, 54, and 20. Now these values are all even, so I know they're all divisible by 2. I'm going to see if that 2 is quite enough for us in terms of factoring. So 10x squared divided by 2 is 5x squared. 54x divided by 2 is 27x. And 20 divided by 2 is 10. 5 is prime, and 27 is not divisible by 5, so I did find my proper GCF. So now that GCF is just going to hang out in front of my problem. It's not going to actually change anything or affect anything. So if you notice, I'm just going to create a couple of steps here, or I have that GCF hanging out front and I don't have to worry about it. So then we're going to proceed like normal. So I'm going to take the A term and multiply it times the C term. So 5 times 10 is 50. So I am looking for the factors of 50 that sum up to or add to make 27. Now when I see a number like 50, I think about money. And to make 50 cents, I know that I have 2 quarters. So 2 plus 25 is 27, and that's what I'm looking for. But you can list off all those values, such as 1 and 50, which are 51, or 5 and 10, which is 15. But I know that I've already found the one that I need. So now I'm going to take that 27x, and I'm going to split it into 2x and 25x, remembering that I need to put a plus between them. So 27x is going to say plus 2x plus 25x. Now don't forget in this part that we still have the 5x squared and we still have the plus 10. Sorry, just fixing my ink flow. There we go. So now I'm going to go ahead and set up my 2 sets of parentheses. making sure that there is a plus in between them. There we are. I've made my plus extra big. And I'm going to factor out the GCF between each of these. So between 5x squared and 2x, the greatest common factor is an x. So this is x times 5x plus 2. In my second set of parentheses, I'm looking at 25x and 10. Those are both divisible by 5. And that again leaves me with 5x plus 2, so I know that I'm on the right track. And then my final step is again to go ahead and write out the stuff that I factored out in terms of GCFs first. So I have x plus 5, and then to also write out the copied set, the 5x plus 2. Now, if you didn't pre-write your GCF, remember that GCF needs to be out here as well. Now, if you did not factor out your GCF, you might get a solution that might look like this. You might get something like 2x plus 10 times 5x plus 2. Or you might also instead get x plus 5 times 10x plus 4. Those are where that 2 is distributed to each set. And they're not inherently wrong, but if your problem tells you to factor out completely, or to factor the problem completely, you want to make sure that you get to the point where we got to on our problem, where that GCF, that 2, is out in the front. Really, it just depends on the needs that you have as you move through your problem. Alrighty, so our next one, again, has some really big numbers in it, a 36, a 39, and a 12. So usually if I have really huge numbers like this, there's probably some kind of GCF. Now 39 is an interesting number in that it really only has one set of factors other than 1 and 39, and that is 3 and 13. So because 3 is less than 12, I'm going to check to see that 3 is my GCF. So if I factor a 3 out, 36x squared divided by 3 is 12x squared. 39x divided by 3 is 13x. And negative 12 divided by 3 is negative 4. Now, 13's prime, the only thing that goes into it are 1 and 13, so I know that I have fully factored out my GCF. So that 3 will be hanging out in front of our problem for the entire remainder of the problem. You might not want to forget it, so I would recommend pre-writing it out like that. So now what we need to do is we need to split apart this 13x. So I'm going to take my a value and multiply it to my c value. So 12 times negative 4 is negative 48. That's what I'm going to find the factors of. And they have to add up to my b term, so they will sum to 13. Now because 48 is negative, I know I'm going to have a positive and a negative value when I list off my factors. But because this sum has to be something positive, the larger number has to be positive. So as I list my factors off, the smaller factors will be negatives. So I know 48 and negative 1, because 1 goes into every number. But that gives me 47. I could do negative 2 and 24. But 24 minus 2 is 22. I know negative 3 and 16. And 16 minus 3 is 13. So I can stop there because I've already found my value. So this 13x, I'm going to call it negative 3x plus 16x. This problem still has a 12x squared, and it still has a minus 4. Now I set up my parentheses, ensuring that I have a plus between them. And then I factor out the GCF of each. So between 12x squared and negative 3x, I know I can factor out a 3x. That leaves this first parentheses with 4x minus 1. In my second set of parentheses, I have a 16x and a 4. So I know I can factor 4 from that, leaving me with another 4x minus 1. And then I gather everything that I've factored out, which is 3x plus 4. And I gather together the pairs. And there you have it. So thank you for joining me with this factoring by grouping video, and until next time.